Hello, everyone. Thanks for joining us for UDI laser marking. My name is Hoon-hee Lee, a product line manager from Coherent Plymouth, Michigan. It is my pleasure to have you on this webinar. We have a co-host, Dr. Roland Meyerhofer, a product line manager from Coherent Munich. Roland?
Thank you, Ini. Thank you, everybody. Welcome, everybody, in this webinar. So my name is Roland Meyerhofer. I'm the product line manager for our Class 1 marking systems in Coherent Munich in Germany, but also for our software, the Laser FrameWork software that we use on our systems and subsystem. And we are going to show you quite in detail what you can do with that regarding UDI marking. So again, thank you for joining our webinar today. And back to you, Honi.
Well, before we dive in, there's a few important housekeeping points. This session is currently being recorded and streamed live on YouTube and LinkedIn. During our presentation, feel free to drop any questions you have in the chat window. We'll make sure to tackle them in the Q&A session. This webinar have four small sessions. I will lead the first session of what is the UDI. Second session is UDI marking process and the 5 steps to getting it right with the unified software of laser framework presented by Roland. And the third session is automation and improve your productivity presented by me again. As the last session, we will have a Q&A. Both Roland and I will answer your questions. All right, so let me start in the first session. UDI, UDI specification. UDI stands for Unified Device Identification. UDI can be displayed in many different forms of label. For example, data metrics, QR code, Aztec, and numerous 2D barcodes are also available to be used for UDI. UDI comes in two sections in format, motion readable in barcode, human readable in alphanumeric. And when it gets to the data level, labels always comes with two parts in data structure. DI, device identifier that you listed to GUDID, PI, product identifier such as expiration date, lot number, and or serial number. However, depend on the issuing agency, data length or structure can be different with the data identifier or check character. Two examples shown at here are GS1 format. In the US, there are three accredited organizations for UDI issuing: GS1, HIBCC, ICCBBA. As mentioned earlier, depend on the agency, required data and formats are different. When we look at the UDI process from top level, process of UDI is basically divided into two sections: preparation and production. At preparation stage, you could submit the product information to GUDID and enlist the data on GUDID at FDA. Production step is applying the information that you enlisted on GUDID data on the product using label. And this is where we could help you to improve your productivity. Depend on the product or goods, it can be marked by laser for quality and durability. However, there might be some specific products that may not be available to laser mark, as UDI is not only applied to metal or plastic parts, but also applied to organic materials. Now let me pass this stage to Roland for UDI marking process and 5 steps to getting it right with the unified software of Laser Framework.
Thank you very much, Huni, for the introduction in the first slides. So I'm going to take over now and going to show you how our Laser Framework software is basically taking care of the whole process chain of UDI laser marking. So we've seen that during my colleague's introduction that UDI is not only just a data matrix code, but also a complete process chain. So therefore, I want to start my part of the presentation with a general view onto the timeline of a laser process and what can be done to control it and at which stage. So the next slide is basically showing you a little timeline. From left to right is the timeline. Typically, It starts at the left side with a variable data input. Sometimes customers are doing a plausibility check. So do these data actually fit to the part that I've loaded? And then in the middle, there's this image of a laser process. Basically, this is where the actual laser process is happening. So there's a time before that, and there's a time after that. And before the laser process, of course, there can be a lot of pre-process control option that can be taken after the process itself. There's post-process control time. So a lot of technologies can be used to really check if the process was delivered okay, was executed okay or not okay. And then at some point, we can also send a report, for example, to a printer or send it back to an MES system or a data point. So this is the timeline. And of course, now we can have a look basically what can be done at which position. And this is really just a general view onto this. So as I said, for the pre-process control on the left-hand side, after the variable data input, possibility check, the part is loaded. Typically, vision systems are coming into play in order to have a look at the part. Is it the right part? Are they loaded correctly? Are they right in the right position, or is something wrong with that? Of course, there's also sometimes fixture sensing. If the clamping is necessary, surface scanning can be applied in that stage of the process. If we step one process step further, so we will actually do the laser marking, there's a lot of technologies available to get the data from the process itself, mainly used for welding, like the OCT, the optical computer tomography, but also the diode-based monitoring and acoustic monitoring is a nice tool to really get a fingerprint of the process and an immediate feedback after the process if it was like expected or maybe off and needs to be corrected. There are more possibilities to check things during the process, but they typically don't apply to laser marking. In the post-process control area, again, there are a lot of technologies available. And for marking, of course, there's the code verification as the number one. But it can also have a look at acoustic emissions again if you do some welding process, for example. And then after quite a while, in a longer frequency, basically you can do a regular system control, check the power of the system, and maybe send all the collected data once a day into a cloud or somewhere else. So basically, this is the time line for a generic process that we use with a laser. And as we can see, the UDI laser marking fits very well into that timeline. So basically, we've got the same sequence. So in the beginning, there's the data, access to the database. We get some data, variable data from there. We need to put that into our system. The UDI code needs to be created. So basically, there's a landing page or landing spot already in our system where the UDI code basically will be created and updated. Then, of course, when the part is loaded, step number 4, we need to see, is it the right component? Is it the position that's also correct? And after that, only the first marking actual laser process will start. So the 5th step is actually the laser marking. So we've got a lot of steps before that. So we call it the UDI Lite process, which is included in the basic system. But of course, there are extended UDI options that can be done, especially the post-process checking of the code that has been lasered, or also the data that have been marked like in a clear text. And I'm going to show you step by step basically how our laser framework software is going to take care about that. So first, what is laser framework software? This is our latest development on the software side for our systems and subsystems. It's one software platform that lets you do almost anything from the workflow to the parameters to the visualization and connectivity of data to our systems. And the intention was basically to have it as intuitive as possible for the process developer and the operator. And as you can see on the left larger image here, you can actually program that timeline into the recipe editor. So you have all the steps that need to be done during the workflow easily by drag and drop from the right-hand side, and then you can execute the job. So let's see then, of course, laser framework is taking care of all the steps basically. So in the pre-process control, part vision takes care through a TTL camera to look at the position of the part, to check the part if it's the right one. During the process control, there's also a possibility to check the emission data, the optical emission data, as well as the acoustic emission data. It's called Smart Sense. Also possible to include in laser framework. In the post-process section, again, vision typically plays the major role in order to check the data and to check the lasered marking content, like shown here with the data metrics code. And of course, on the longer time frame, basically you do some system monitoring. If we have a cloud connection, you can check the efficiency of your process, the overall equipment efficiency, but as well also stage the condition of your laser system. So let's jump into the UDI process step by step. So first one is the access to the database. So basically, there is information that needs to be drawn from the database. It needs to be put into the laser system. So for that, we typically see that the travel card is used where the samples are placed with. And if you scan that barcode, you basically can put the data into the laser system. So with the data input, basically it lands in laser framework. The host data link is the connection point to the outer world, basically in our software. And there, those variable data basically will be transmitted and put into the right place, basically the job that or recipe that's already waiting for it. And then you can create the UDI code. So you've got your recipe with the variable data spots basically that are waiting for the input from the database and from the host data link. And then you can update each and every element basically of your marking content. And such the UDI code is generated out of that transition. So the next step, step number 4, component and position recognition, as I said, is mainly done through vision systems, vision and pattern recognition, in this case through the lens camera for high resolution. So we are looking at the position of the parts and check each position based on what has been programmed as a search position. In this case, if you can see on the right-hand side, this is a pacemaker, and there are 4 holes that we can use for alignment. And if they're not in the right position, then of course we are going to align the marking content accordingly. And this is also shown later on in the video. And finally, we are marking then the samples. In this case, we use a picosecond laser for the precise black marking, a very nice marking technology, basically based on nanoripples that are created. And this is a really nice black coloring of metal surfaces. And it's also nicely visible basically from almost any angle that you look at. So it's really a nice black marking using the picosecond laser. But of course, with all kinds of other laser configurations available in order to optimize the marking contrast based on the material that needs to be marked. And then we come to the optional extended UDI content. And first step of this optional extended UDI content is the UDI code reading. So basically we are able to check basically what has been marked, if the content is the right one. So we are comparing the content to the programmed one, but we can also have a grading basically of the code. So this will give you an information how good the code is. So according to the typical standards that are used internationally on that, it's not exactly that standard because we're using a different illumination in our system than in the standards, but it's based on that. And we can also print the results of that code reading and the grading, for example, to a printer that's right beside the system, just by adding a printer device to our laser framework software architecture. And thus we can check what has been done and how good it is. And the final step, step number 7 now, is the optional marking data check. So also the optical character recognition, the reading of a clear text can be done and can be programmed in our software in order to see, was it okay? Was it exactly as expected? Is the grading also okay? And if that's all okay, basically we will send the information back to wherever the customer wants it. Basically, it can be stored locally. It can be sent to a computer on premise. It can be sent to the printer, as I said, right beside the machine, or to a cloud server in order to collect the data over a longer time frame and see the performance of the machine. So all that is possible using Laser FrameWork. And now, basically, we want to show you in a little video how Laser FrameWork is used basically for the preparation, um, typically done by a process developer, and the execution typically done by the operator. And this will basically go through all the steps of the UDI laser marking. So please start the video.
Within this short video, we are going to show you how easy laser marking jobs can be prepared and executed with Laser FrameWork. The first part is the preparation of a recipe. This can be done offline or at the machine. This is the recipe editor. The user can select predefined tasks on the right-hand side and move it to the timeline, for example a laser marking task, vision tasks, or live view for the operator. The next step of the job preparation is the definition of the selected tasks, starting with the marking content. Here, we want to mark a logo, a GS1 data matrix code, and a serial number containing variable data. Now we can easily program the pre- and post-vision tasks. For the part alignment, we are selecting a 2-point search for the holes in the pacemaker samples. Now, with a few clicks, the post-process code verification step is set up. First, defining the region of interest on an already marked sample, teaching the code content, and finally testing the result. Likewise, also the OCR reading task is set up. Here, we are using filter functions in order to enhance the contrast in the region of interest. Now, the recipe generation is completed and we can start processing parts at the exact Mark 230 system. The operator is now going to load a tray with pacemaker housings into the machine. By scanning of the barcode on the travel card, the right job program is automatically selected. The marking job can now be executed. With the live view camera option activated in the recipe, the operator can watch the progress of the marking process. As the marking of all parts of the 3x3 matrix is completed, the operator can now check all the results of the programmed post-inspection. First, he is checking the saved images of the pattern recognition, then the results of the verification of the data matrix codes, and finally of the OCR text.
All right. I hope you can see that it's not that difficult to program and execute even a complex workflow in Laser Framework. At least at the end, the operator, which is actually our application innovation manager, was happy with the result. So now I want to um, continue slightly with another option for pre-process control, especially for odd-shaped parts. So we are having a prerequisite for that, and that's the fast focusing module that's necessary in order to work on 3D shaped parts in a certain depth. But it's really a nice and convenient way to do that. And what we do that for is basically we use a 3D line scanner in order to take the position of that 3D parts that are placed underneath the galvo head, and we produce a point cloud and then basically adjust the marking layout to that in order to have the marking exactly where the part is. So this could be used for odd-shaped parts. Could also be used for parts that are not exactly flat underneath the galvo head. So it's a very nice opportunity or technology to really mark the parts where they are, even if they are odd shaped. And of course, as a prerequisite, as I said already, you need a fast focusing module because you need to adapt the focus fairly quickly to the shape of the part. And this really allows us to mark on 3D shaped parts or rotary parts or parts that have got a slope or an angle to it, like the parts shown on the right-hand side in stainless steel, but also in plastic material. And this is a nice way, basically, to work on 3D parts. So that's just as an intermediate summary now. We've got all kinds of marking solution from desktop to fully integrated solutions, standalone solutions. Quite versatile because we probably have the widest range of laser sources, wavelengths and pulse width and power levels in the market. And we can use them on to optimize processes basically on any material. Especially that I showed you is the ultra short pulsed laser marking, the corrosion resistant marking, so-called black marking, to create basically a nanoripple structure rather than just a thin oxidized layer that used to be created when we used nanosecond lasers. So this is really nice possibility to have a real high contrast with a good corrosion resistance, even after several autoclaving procedures. It's still quite visible and still black. So we've got complete solutions, integration into product lines with vision, with motion, process monitoring, as I've shown you, with data handling, and from manual loading, which I've shown in the video and throughout my presentation. But of course, we also got some nice automatic loading and unloading capabilities, and I'm going to give it back to Uni now to show you more about that. Thank you very much.
Thank you, Roland. There are several levels of automations available. Standalone inline integration, designated machine by integrator. And I'd like to introduce Exact Mark 210TL, which is a standalone machine for universal applications as an example. However, you could find a similar benefit from other automation solutions, though each solution would have a very distinctive budget requirement. To understand automation, I'd like to show you an example of Exact Mark 210TL. Exact Mark 210TL, 210 Basic is manual system requires a dedicated operator to loading and unloading parts. Exact Mark 210TL Ready is manual system ready to automate, as not every customer has the volume to process in automated system from the start. This system offers an option to upgrade later on with automatic loader and or robot system when production start to ramp up. ExecMark 210TL is automated system with a tray loader and or 6-axis robot. This option allows user to select either top marks or top and bottom mark or even cylindrical workpieces in batch to be marked automatically. To be called as an automated system, it requires automated part loading and unloading system. This automatic loading and unloading helps to increase the MTBA, which stands for mean time between assistants. Automated handling systems should be able to improve yield rate by adapting vision system, which ensures consistent accuracy on part handling and marking position. Also, automated systems should be able to verify the mark result via vision system. With the mentioned feature, users could benefit on saving operator with increased MTBA, ensure accuracy with automated process supported by vision system. On next two slides, I'd like to present some examples of productivity comparison between 5 different machine types on different applications. This part is pacemaker with the size of 42 millimeter by 56 millimeter. Marking time is 15 seconds per side. 12 parts can be loaded onto a tray, and tray can be stacked up to 30, which can be loaded at once. This makes 360 parts per batch. There are 4 different system types: manual, turntable, pallet system, and tray system. It can be tray only or tray with a robot. Manual system and the turntable requires dedicated operator to feed every single part twice, as it has to be turned upside down to mark on top and bottom. While pallet systems and tray loader can be processed a bunch of parts with a single load, but it still requires operator to flip the parts either on a pallet or tray. When we look at the MTBA line, a pallet system has a 551 second. Tray loader can have a 3,800 second, which is close to 7 times better than pallet type. Also, when it goes to the tray with the robot, it increased to 7,400 second, which is 13 times better than pallet system, as it will eliminate the need of operator to flip the part. On the cost saving on operator per year, which is based on the annual salary of $38,000 for typical operator. Trade system could save up to 2.3 million per year only from reducing an operator. This calculation is based on the assumption that loading and unloading only takes a minute, and a single operator could operate up to 63 machines based on the calculated MTBA. However, this number does not sound realistic. The single operator could run up to 63 machines. So, if I divided total saving with the number of machines, it turned out to be 37,000 per machine per year, which means it can be write off in less than 5 years, only with the savings from the reducing operator. This is catheter. Part size is a 13 by 25 millimeter. Marking time is 2.9 seconds per side, and 68 parts can be loaded onto a tray, which makes 1,360 parts per batch in 20 trays, while 220 parts can be loaded onto the pallet. Let's look at the number of parts per day. When manual system produce 1,133 parts per day, turntable will produce 1,367 parts, which is approximately 121% increase in productivity compared to the manual system, and the productivity is on the third line from the top. Pallet system will produce 3,361 parts per day with the 297% increase in productivity compared to the manual system. Tray system will produce 3,691 parts with a 326% increase, while tray with a robot will produce 4,147 with a 366% increase in productivity. Again, another important factor is MTBA. While manual system has a 10 second, turntable will have a 9 second. pallet system will have 738 seconds, which is equal to 12 minutes. And tray system will have a 2,901 seconds, which is 48 minutes. Tray with the robot will have a 5,662 seconds, which is 94 minutes. Considering each load will takes about a minute, max number of machine operated by single operator are 12 on pallet system, 48 on tray, and 94 for tray with a robot. Cost saving on operator will be 430,000 or 35K per machine per year on pallet system and 1.8 million or 37K per machine per year on tray system. Lots of manufacturers were invested on turntable and pallet system with the XY table to improve productivity. Though it shows that the tray system could produce more with a longer MTBA and a shorter ROI with a huge saving on an operator. As I mentioned on earlier slide, there are other types of automations available, such as inline or customized solution by integrator. However, those are typically pretty expensive compared to the standalone machine. ExactMark 210TL is a standard system with a modular design to adapt optional features on the field easily. Unlike inline or integrator solution, ExactMark 210TL is compact and includes lots of features as a standard features, such as vision system and a barcode scanner. And most of all, this machine is designed to increase MTBA to save on operating cost. Increased MTBA means single operator can tend more machines or work on other tasks longer. ExactMark 210TL comes with the three main options. Tray loader, which you could select either stack type or magazine type. If your parts are less than 10 millimeter, you could use a stack type to maximize the MTBA. Though if your parts are taller, then you could use magazine type, which allow you to use up to 40 millimeter parts. Second option is a 6-axis robot. If you need to mark a top and bottom or cylindrical workpieces, this 6-axis robot will help you to increase the MTBA. Also, this solution will help you to improve part positioning on the marking zone, as the robot will present parts at the same position every time, and a vision system will ensure that absolute accuracy. Parts can be fed through tray or pallet. Last option would be pallet and a manual table. This is recommended for robot application. However, if you need to process a single or low volume, you may utilize the table. Pattern bolt holes help you mounting fixtures if you need it. Let's look at the movie clip of ExactMark 210TL with the robot for top and bottom marking. ExactMark 210TL is based on the ExactMark 210 Basic. This machine can be used for topside marking with a tray loader only. Engaging of components such as a robot can be programmed from recipe file with the drag and drop. When you select the robot option, it enables you to process top and bottom marking or cylindrical parts marking. Unlike many other robot systems, Laser Framework eliminates the need to set the robot with a teach pendant, which could be intimidating to operators or the technicians. Instead, a laser framework allows you to simply input palette information and a mark position with the offset values. Part Division Advanced will ensure you the part positioning and correction per part prior to the mark. The same vision system can be used for mark verification. Let's look at the remaining movie clip of ExactMark 210 TL with the robot for cylindrical parts. Now we will move to the next session of a Q&A. If you have any questions on the UDI or automation, please let us know via chat window. So let's look at the chat window. So
there are already a couple of questions there, so I can take the first one, I think. So there's a question from Jordan. You mentioned a diode-based in-process monitoring solution normally used for welding. Can that also be applied to shorter pulse applications like marking or engraving? That's a very good question, but the answer is yes, because also from marking processes, even using ultra-short pulse lasers, there's a lot of light emitted that we can capture. So we've got fast enough detection in our SmartSense Plus. That's how the product is called, process monitoring solution. So actually, yes, we could theoretically also capture those shorter pulses as well. Another question, I can take that. It's about vision, right?
Yep.
What kind of vision options are available with your laser framework software? So we've got two packages basically. So we've got a hardware part that's coming with a vision package. It's the illumination, that's the camera. And of course, there's an associated software package. And we have a variety of options there. You've seen the 1.2 point search. You can have an autofocus basically based on the image sharpness value. You really have a lot of options to check pre and post vision topics as well as our software, but would be a long story to tell everything what we've got in this two packages. Maybe we can do it afterwards.
Do you want to cover that the laser framework software? Yep, the vision options for vision on cylindrical parts.
How accurate is the vision on cylindrical parts? It depends on the features we have to look for. The vision process itself is quite precise, so I would say in the single-digit micron range for a short focal length. But of course, it depends basically on the features on the part, how good they are, how good the contrast is, how sharp they are, basically.
Yeah.
If it's
also,
a molded
I
part,
believe that is related to focal length too.
Yeah. Right.
Yep. So,
okay. Another one.
The Massa
Yeah. Yes. Software solution looks great. Thank you. Do you offer this as a standalone package? No, right now, actually, this is part of our system solution or subsystem solution. So we only sell it together with a laser or with a system because it's highly embedded and also tailored to our systems. We are not offering that as a standalone product at the moment, but might be a nice idea for the future.
Okay. And do you want to cover the next one?
Do we have predetermined parameters for different materials to prevent corrosion for validation purposes? Yes, we do have quite a set of parameters that have been developed over the years on different lasers, but of course this is more referring to the black marking application using picosecond laser. And of course we've got a pretty solid database, what kind of parameters we have to use in order to get the best corrosion resistance out of that.
Yep. And I have a next question from Masa. I have a different application. Can you run this productivity calculation? Sure. When you send me the application information, I will run the productivity calculation and send you the report. And
okay, this is a tricky question from Christian. Are there beam shaping options available to reduce the need for focus shifting when working with curved parts? I mean, we are using the focus shifting in order to have the smallest possible spot size, and we can use this really fairly quickly. So basically in between the jumps, so there's almost no time delay using the fast focus module. But I might not get the question well enough. At the moment, I would say we don't have any beam shaping optics that would cover the 3D shape. Just we would modify the beam spot size, for example, or the profile with beam shaping optics. That's for sure.
And I take the next question of what kind of a tray can be used on the tray loader. Okay, so this exact Mark 210 TL uses a JEDEC tray, which is a 322 by 135 in millimeter. This JEDEC tray has been used in semiconductor industry for decades. For the magazine type, customer could use custom build, or they can build their own trays as long as the outer dimensions match with the JEDEC standard. So there's a lot of options. Okay.
All right, there's one that came in right at the same time, which is the question from LinkedIn. Good evening. What's the laser power output? So of course we've got a variety of lasers that we use, typically ranging from 10 watts average power to 100 watts. Specifically talking about the picosecond laser for black marking, that's a 30-watt laser. But this is the range typically we are operating. Oh, that's another nice question for you. The next one with the cobot.
So
from LinkedIn.
Question from LinkedIn. You have a developed integration with the cobot system. Is that a question?
There's no question mark at least, but it could also be a statement because you haven't shown it in the video.
So this is 6-axis robot we integrated into the system, and we used a couple of different robots to best suit for the application and for universal applications. So there's a specific robot that we choose. Yep.
Okay. Next question. Yeah, I can take a best solution for marking of tubes made from PBACs. I personally don't have the experience on that. I would start with a UV laser as a first choice. Might also be a CO2 laser in the near infrared as an option, which we still have as a marking solution. But I would have to run it through our application colleagues. Unfortunately, I cannot answer this right away at this point.
Okay, and next question is into the market.
Should I read the question
Yep.
from Stephen? Okay. Being very new to this technology, we are looking into marking medical parts. However, we could do with a steer towards the level of clean that would be required for this process, which we believe would be over and above what we would require for marking automotive parts. That's for sure. Are you able to help or direct us to someone internally that could help us with that? Yes, of course, we can help you due to our many years long experience on marking of medical parts in our systems. We can for sure get in touch with you and hopefully explain you what kind of cleanliness level needs to be applied for those parts.
And is there any other
Oh,
questions?
Okay, that's just so it's about clean room.
Yeah.
Yep. So also about the clean room, we don't really have clean room certified systems because, but they are clean room compatible most of the time. The only thing you have to take care of basically is the exhaust that needs to be outside of the clean room in order not to create any dust from that. But
and also, it is important to let us know, what classroom classification that you're requiring.
yeah.
Okay. Any other questions? The last minute questions. Okay. Due to the time limit, the rest of the question will be answered individually after the webinar. And there's a couple questions that we skipped through or we missed that it will be answered individually after the webinar. Please follow us on the social media channel you see on the screen later on. Thanks for joining, and don't hesitate to reach out for more information. By the way, if you are interested to see the live demo of this ExactMark 210 TL or the robot, we will demonstrate it on the MDN West in February. Okay. Thanks for joining us this webinar. Have a wonderful day.
Thank you very much for joining. Thank you. Bye.